Hello man, how are you? I don't have enough time to amaze you with long explanations. So, in order to answer your question, I will try to use a blackboard a very short explanations of my ideas about the difference between the people that you try to reproduce by means of console and my own one. What is the first difference? The first difference is the generation rate that is using in the continuous equations. And speaking about G in this paper that correspond with this expression H. But the difference start by the general Helmholtz equation. So I will try to explain you what things the author take into account. In different with my own work. Okay, I take this equation. It is, as you know very well, the Faraday law and the Ampere's-Maxwell law. The constitutive equations okay, I take the core operator in both sides of this equation. If I write this, something that is evident that the author of this paper done in their work, if you, in that case, you suppose that the magnetic permeability doesn't depend on time. What else? Now, we'll write here this equation. So I can write this partial respect to time G plus epsilon plus E respect to time. In this supposition, also epsilon doesn't depend on time. The electric permittivity doesn't depend on time. What else? Here, the author supposes that all current is the time, or the type, sorry, ohmic current. It means that the current is defined with this equation. Okay? In that case, we can write minus mu respect to time sigma plus epsilon E respect to time. Okay. In addition, the author supposed that electric field, this electric field is equal to an amplitude electric field, could be the total electric field right here if you want T everywhere. Okay, I'm going to use this notation in order to make easy the understanding of my explanation. Is equal to an harmonic signal. Okay, with this, the first derivative in time of this equation is minus G omega the electric field, the amplitude, and the second derivative is equal to this T minus omega squared, sorry, this is plus because it was positive, square GBG is minus this expression. This is the second derivative, right? Now, if we replace these values as in the equation, we can write minus multiply sigma G omega the electric field, the amplitude. I remove this part from the equation. I have only the spatial distribution of the electric field with I remove the time dependence in the equation. So sorry, this is minus. Okay, allow me to check that everything is right. I think it is okay. Perfect. Now I can play a little with number and to write here this number like mu r multiply 0 and move this parameter outside of the equation by epsilon move this here, write epsilon r multiply by epsilon 0. This could be into the equation. So here I have only epsilon 0 and epsilon r, and here I have epsilon r only, right? Sorry, I make a little mistake. Now it's perfect. This parameter, where I remove this, I have at the end this is square, this is the speed of light. In addition, I know that frequency square is 2p nu square. So I can write here this frequency. All me to write here this minus omega square omega, and here it is anything. So I can write here this and replace by its value, which is 2p nu square. This is the y-length multiplied by the frequency square. So 2p over lambda is 0. At the end, this parameter disappears with this parameter, and I have this key, the wave number vector square. So I can write here minus r multiplied by q r square. Okay, what else? This can be replaced by 2p nu and multiply here lambda and lambda. By doing this, this product is equal to Z0. Okay, yes, or Z, the speed of light. Now, I think that the equation is exactly the same, because I can move this to here and write move this on the other side, plus minus Kelvin square epsilon r minus sigma g lambda epsilon 0 to pc by the electric field. This equation equals 0 is a Helmholtz equation quite different than the one I used to solve my lecture. In the page number, allow me to check the document 66 of my thesis that I have linked to the mail. You can read the equation that I used. Use an equation that is the Helmholtz equation. The amplitude of the electric field is the same function that I use. I calculate the second derivative, because what is the main difference between this and my calculation? If I write this, this is the Helmholtz equation, simple Helmholtz equation. I tell you that this homogeneous behavior of the electric permittivity. I can explain you. This equation supposes that the electric permittivity could be non-homogeneous along the space. There is an identity. The identity says that the curve of any vector is equal to the gradient of the divergence of this electric vector minus the Laplacian of the vector. But I have supposed that this number is 0, the Gauss law. This is equal to 0. In my calculation, I solve this for the laser to achieve the model for the rate generation of charge. What I suppose here? I suppose here that in the first step there is a charge here. The Gauss law in general is this expression. Someone can to transform this expression in this equation. Where this means that the epsilon E is equal to the gradient of E multiplied by epsilon, where there is a change in the space. It is 0. Okay, it is an homogeneous parameter in all the space. And the second, you suppose that there is a free charge distribution in the device along the illumination process. Something this is not true, absolutely true, because when you start the process, a pure charge, and really you have to take into account this term in the equation, and of course with the generalized expression you have taken this expression into account. I think this expression neglected some real effects, some real physical events in the process, but are more accurate that my own equation for to model the laser space distribution of energy, because at the end I get from here the intensity of power like the square of the amplitude. They do the same, but from this expression, of course, their generation of charge along the transit process is more realistic. Okay, this is better. This expression is better. What else? You want to know how they calculate the electric field radiated by the system. Of course, they solve the Poisson equation, right? I've forgotten this. This is the equation number 9 here, right? I have simplified it. I solved this equation only one time. This equation is solved when there is a laser, when the system is in the dark, and we have a steady state of charge distribution. Of course, the equilibrium of charge is given, in my case, by this simple calculation. The gradient of the potential, this potential, is minus electric field, or vice versa. You can write this as you want. Okay, in the same case, this man calculate the potential along the transit process, and all the time he can get electric field through the potential with this expression. How to do this with console? I do not how to do this. I hope that you understand my explanation, and you can reproduce with effects this paper. I wish you the best, good luck, that's all. See you, ma'am. Bye bye.